So let's check out this question. So remember, the first thing we always want to do is read the question, RTQ. So what are we asking for, everybody? Give me a word or a phrase. What are we looking for when it says, what is the final price he pays for the shoes? What are we looking for? Yeah, that's right. One way to say it is we're looking for the final price. Final price. So when we think about everything we see here, everybody, what's the information that we see? Well, I'm going to spot it here. It says the pair of shoes originally cost $60. And I also see that there's a 20% discount on those shoes. My party people, this is how you can tell whether or not you're on the right track. Watch this. I'm going to write this 20% times the original $60. If I were to just write this out, everybody, what is this number going to represent? I don't care what number it actually is. Don't tell me 12, 24, whatever. Don't tell me any of that. I don't care about that. What is this going to represent? What is that going to represent? Yeah, I know it's going to be the result. I know the formula says that this is where the result belongs. But what is this going to represent? Yes, it is going to be the discount. It is going to represent the discount. How do I know that, everybody? Well, tell me, what does this represent over here? What does the 20% represent? Yeah, it's the discount. It's right there. That is the percent of the discount. And so therefore, everybody, because the percent that you apply and the result that you get, they represent the same thing. Because of that, these both represent the discount if you were to set it up like this. Why is that a problem? Well, everybody, are we being asked to find the amount of the discount? No, we're not. That's right. We are not asked to find that. We want the final price. So if we wanted the final price, we would want to plug in the final percent if we wanted to get the correct answer immediately. But let's just suppose that we did the 20% anyway, just to show you what's up. So we would have 0.2, because again, move it over twice. We can get rid of that last zero there. So 0.2 multiplied by 60. Let me show you that right here. 60 multiplied by 0.2. So we have 0 multiplied by 2, and that'll be 0. Then we have 6 multiplied by 2, and that'll be 12. How many decimal places do we bring back? None here, 1 there. Just 1 decimal place that we'll bring back, and that is a $12 discount. That's not the answer A. That's not the answer because, again, we wanted the final price. So because of that, all we would need to do if we did that was take the original $60, subtract the $12 of the discount, and that'll give us the final price. So 60 minus 12 would give us 48 in this case. That's the final. Now, my party people, with that said, if we wanted to do this in one shot, not one, then 2 steps, if we wanted to get this done in 1 step, well, this is how we would do it. If we want to do that, let me get this over here and make it a little smaller. All right. Now, if we wanted the final price, we want the final percent. And the final percent would be the original 100% minus the 20% discount, and that would be 80%. That's the final percentage. So what we would have is right over here. So this right here would turn into 80% times the $60, and that'll give us the final price. Who here sees where I'm going with this? Who sees, yeah, this is actually starting to make a lot of sense, and I see how to manipulate this. I see how to rework this. Perfect. The next lesson, oh man, I can't wait to do all straight up practice problems. This is going to be so much fun. Here we go. So let me zoom on in and just do the same math so I can show you the right answer. So here we are. We have 60 multiplied by, move it over twice. So that'll be 0.8. 0 times 8. 6 times 8 is 48. Bring one decimal place back. And there you go. Final price, $48. And you get it in one shot, not two shots over here. That's what it's all about, everybody. Being able to work the same problem that everybody else is doing, but in the most optimal fashion to save as much time. So with that said, my party people, are we ready for the next one? We ready to try one more out? Right on, let's go. So with that, let's move it over here. So next question up, we're solving for x. And what we see here solving for x is we have a parentheses on the left, and then we have variables on the left and the right sides. So typically when it comes to solving equations, we're just trying to work backwards. But before you can work backwards, we have a little bit to get out of the way. So the first thing I'll do is I'm going to consider dividing both sides by 8. Instead of distributing, I'm going to consider dividing, but I'm going to stop right there because, well, 6 divided by 8, that's going to make a fraction, and I don't want to do that. So instead, I'll just commit to the distribution, doing 8 multiplied by x, which that'll give me 8x. But don't forget to distribute the 8 to both terms. Got to distribute to the 13 as well. Very easy to get this question wrong if you forget to distribute the 13. So here we go. Let's go ahead and just on the side over here, do 13 multiplied by 8. 3 times 8 is 24. Then we have 1 times 8 plus 2. So there we go. That'll be 104. We have 8x plus 104 equals 6x plus 196. So now we can go ahead and continue with moving the x's to be on the same side. So we can choose either direction. We can move the 8x to the right or 6x to the left, but I'm going to subtract the 6x because I want to keep things positive just in case, we make a mistake with negatives. So I'll subtract 6x there and there to cover both sides. And once I do that, it cancels on the right, leaving me with 2x plus 104 equals 196. So from here, what we're going to continue with is just like we would with a regular old equation. Let's get rid of that 104 by subtracting it on both sides. And then from here, it cancels on the left, leaving us with 2x equals, and this would be 92. From here, everybody, we'll go ahead and divide both sides by 2. And then we ask ourselves, how many times does 2 group into 92? And the answer to that will be 46. We can prove that with some long division if we'd like to. 2 going into 9 4 times. Subtracting the 8 to get 1 by itself. And then we drop the 2 to make 12. 2 going into 12 6 times. So again, we can go ahead, perform that with mental math, but either way, the same correct answer will be 46. Answer choice B.